everyone, welcome back. So today's topic is about inductive transducers in basic electronics. An inductive transducer is a type of measurement device that works on the principle of electromagnetic induction. So it covers a physical quantity such as displacement, force, pressure or temperature into an electrical signal that can be measured and analyzed. So there are two types of inductive transducers. The first one is variable reluctance transducer and the second one is linear variable differential transducers. A variable reluctance transducer uses the change in reluctance of an air gap in the magnetic path to measure the displacement. The transducer typically consists of a coil of wire wrapped around the magnetic core with an air gap between the core and movable ferromagnetic target. M is equals to mu naught into A, which we'll take as equation 1, where I is total air gap length and mu naught is permittivity of free space and A is air gap cross-sectional area. And inductance at the coil terminals is inversely proportional to the reluctance. Therefore, the equation is L is equals to N square mu naught by L. N is the number of turns, R is reluctance of the magnet. We'll write inductance at the coil terminals as L is equals to K by E. So the second one is linear variable differential transducer. An LVDT is a transformer with one primary winding, two secondary windings and an adjustable iron core. So this is a picture of it. LVDT's primary winding, P is energized by a constant amplitude AC source. The magnetic flux thus developed in a couple by the core to the adjacent secondary windings S1 and S2. If the core is located midway between S1 and S2, equal flux is coupled to each secondary, so the voltages E1 and E2 induced in windings S1 and S2 respectively. At the reference midway core position known as null point, if the core is moved closer to S1 than S2, more flux is coupled at S1 and less to S2. So the induced voltage E1 is increased while E2 is decreased, resulting in the differential voltage E1 minus E2. And if the core is moved closer to S2, more flux is coupled to S2 and less to S1. So E2 is increased as E1 is decreased, resulting in the voltage E2 minus E1. So this is the graph of difference output voltage versus displacement curve of LVDT. So the advantages of LVDT is ruggedness, high sensitivity, good linearity, infinite resolution, lower power consumption, and disadvantages are large core moments required to get measurable output and coarse mass limits response. Thank you for watching.